Kirchhoff law. Kirchhoff law. Write down. It states that it states that it states that the total current or charge entering a junction or a node is exactly equal to the charge leaving the node so sum of I in will be equals to write down the sum of current in should be equals to sum of current out. Sum of I in will be equals to I out, no? I'll give a question now. Okay, write the equation. Find the magnitude of current. In PQ, in P and Q. Find the magnitude of current in P and Q. This is the equation. What is the current you need to find? How much current it is flowing here? What is the answer? 8. Okay, listen here. Listen. So how much current is here? So in this point it has been divided into two parts. So 4 and 2, 6. Right, no? So if 6 is going here, how much will be here? 6, no? So 6, and at this point 1 has been went here. So remaining will be 5. So 5 plus 3 is? 8. That's it. 8 is the answer. Huh? Which one? 15 minus 7. Whatever it is. So got the answers, no? Okay. So one more law is there in the Kirchhoff, no? That is the voltage in a circular path, in a closed loop, will be equals to 0. So based on that we will do problems now. Completed this one. So try to understand the steps here. I will give 4 different cases. So first one, A and B. This is 2 volt and this is 10 volt. Second case is connected to earth. This is A and this is B, and this one is 5 volt. Third case, 10 volt having a resistance 3 ohms and current is flowing 2 ampere, and this is point B. And the fourth one is four ampere is going, resistance 2 ohms, and it is earth B A. Okay, first let me tell the points. You can take down the points and then we'll do this sums. Step number 1, write down. Step number 1, start at any one point, either left or right. Start at any one point, either left or right, and ends at other point, So if I start at A, I should end at B. If I start with B, I should end with A. Second point, find whether the potentials are increasing or decreasing. 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 Okay. So here how to find is, these are my potentials, no? 10, 5 are my potentials, like the batteries. If I am going like this, for example, in this direction, this is my positive and this is my negative, no? I have entered in positive but came out as negative, so which means it should be minus only. If this is my direction, so I have entered in positive but came out as, entered in negative, came out as positive. Okay, so remember these two things. You can draw that one. And third point I will say, so you can choose whatever point you want, like either A or B, but I need to check whether the current flowing in my direction or in opposite direction. Okay, if I start, for example, if I take this fourth example, if I start with A, I am going from A to B, current is in the direction of with me only. If I start with B, current is in opposite direction of with me, right? No, so these two cases I need to notice here. So the next point, step number 3, no, check whether the current flow, in the direction or opposite direction, So after checking, no, if it is in the direction, into your direction, I should consider that as a negative. Okay, I should consider that as negative. And if it is in opposite direction, I should consider that as a positive, because like morning I have told, field will be in opposite direction of the current and current will be in opposite direction of the field, right? No, yes or no? So this point is like, if I am going opposite to the current, it should be considered as positive. If I go in the same direction as current, I should be considered as a negative. Okay, so once again you see the points and we'll do these problems now. Done? try to analyze only whatever I am saying, don't ever insert something in your mind. Okay, can we start now? The first one, so I will start with the potential A. Let me write VA. I am going in this direction. Let me take this my direction. So I am entering in positive, exits in negative. So minus 5. Okay, minus 5 should be equals to 2. That is nothing but VB. The potential, no, like I am talking about the potential difference. Okay, VA minus VB should be equals to 0. So minus VB I have taken to this side, so which is nothing but plus VB. Okay, the potential difference I am talking. So delta V I am talking, potential difference between A and B. Okay, which one? Which one? This is 10. Okay, 10 only, no? So VA minus 10 should be equals to VB. What is VB they have given? 2. So VA minus 10 should be equals to 2. So VA will be equals to 12. Okay, I have started with one point, I have ended at other point. Suppose if I start like this, okay, which is nothing but VB minus or plus 10 should be equals to VA. What is VB? So 2 plus 10 equals to VA. I am getting VA as 12. I am getting, no, either way if I start I will get the same answer. Any doubt in the first one? I will go for the second one. Don't copy, let me complete. So I have start with the second one with A. So VA, so entering in minus, exit in plus. So plus 5 should be equals to VB, but it is earth, no, when I connected with earth the potential will be 0. So 0 plus 5 will be equals to VB, which is nothing but VB equals to 5. So this is second one. Third one will do. So third one I will start with A. So potential A, I am going in the in this direction. So current is in which direction? In the same direction, no? I am going in this direction, current also same direction. But here resistance has been given. We know the formula, V is equals to IR. So current is 2 ampere, resistance is 3 ohms. So I am in the direction of the current, so minus symbol first. 3 times 2 should be equals to VB. Any doubt here? So VA minus VB should be equals to 6. This is the answer for the third one. And for the fourth one, so I will start with VA going in the direction of the currents, which means minus 4 times 2 should be equals to 0. Earthing, no? If it is earthing, I should consider that potential as 0. So VA will be equals to 8. So once you copy down, if anyone having doubt, call me, I will explain. Which one? Which one? Third one, what happened? Okay. So if it is 10 minus 6 equals to VB, then VB equals to 4. Okay. So if you are having any doubts, please let me know. I will give a problem now. This is one of the important problem in either JEE mains, EAPCET or NEET point of view. So those who have completed the first fourth question, you can do the fifth question. This is fifth one. So once we'll complete this 5 circuits, no, we'll go for the complicated circuits. Last one. Answer. VA minus VB, I need to find the potential difference. 9. Done. Nine is the answer for the fifth one. So this is the diagram. Completed the previous question? Anyone any doubts in the previous questions? I'll do that question. Try to listen here. Listen here. Don't write anything. Listen. So I'll start with A. So I'm going in the direction of the current, which means minus. So minus, it is resistance has been given. So current into resistance is the voltage. Again plus to minus I am going. So minus 3. Again in the direction of the current, which means again minus 2 times 1 should be equals to VB. The question is what is the potential difference across the given circuit, which means VA minus VB. So 2 2 are 4, 4 plus 3 7, 7 plus 2 9. That's the answer. Either way if you do, you will get the answer. Okay. Now this is the question. Listen, don't write anything. Listen. Completed this one. If you have not completed, please take down fast. If you try to understand the loop, you can do any problem. So till now we were talking about only the potential difference across the circuit, like what is the potential difference, VA minus VB or VB minus VA. Now we are using the voltage law. The circular path should be equals to 0. The sum of potential in the circular path should be equals to 0. That's the one law. No, one law is talking about the current, the second law is talking about the voltage. Okay. So first point I will tell you here. Completed. Done. Okay, listen. Either you can start with any one of the point, any one corner. Okay, any one corner. If I start either here or here, no issues. But if you start here, take a circular path, come to the same junction. Okay, this is my circular path. Okay. So circular path should be equals to 0. Closed loop should be equals to 0. No. Now if I talk here, I am going in this direction. No. So in this direction there is no potential, but resistance and current has been given. So I am going in the direction of current or opposite direction of the current? In the direction of current. So minus I3 R3. Leave as it is. Now is there any other things? I am going here, again the voltage like potential is there. So positive to negative I am going. So which means minus E1. EMF, no? E1. Now again resistance I am facing here. So but current direction is in opposite direction, which means plus I0 R1. Any doubt? Nothing is there. Again I am facing the battery, that is negative to positive I am going. So plus E1 plus E2. So they have given the current direction, no use of that for me right now. If there is a resistance, I can take the current direction. Again I am going to resistance in the direction or opposite direction, minus I2 R2 should be equals to 0. That's it. Okay. Closed path I have taken. Either I can start with any point. So I have started here, going in this direction and coming to the same point. So this is my equation. Take down. Oh my God. So any doubt in these loops? Any doubts? Can I give you question? Can I give question? No. Okay. Question I'll give. Try to do this. Ohms, 3 ohms, 2 ohms, 3 ohms and 12 volt. So this is the diagram. I need to find what is the current flowing in this circuit. Okay, this is the diagram. Listen, I'll give a hint here. So I can take this as the one loop, started here and ended here. Okay, and I can take this as the other loop.